Hello there everyone and welcome to this challenge, Pandas Challenge Day 2. My name is Valentine and I'll be your instructor. In this challenge, we are going to be going through various concepts in relation to pandas, and we will be building up towards having an understanding of the pandas library when it comes to data manipulation, data analysis, as well as just generally data collection. So yeah, so if this is your first time, you can check out the Pandas Challenge on day 1, and you can get started with that. And if you're interested in doing the entire challenge, be sure to have a look at the other link, the email subscription challenge link that allows you to get an email every day when it comes to just these challenges. You always get a reminder to work on these challenges. All right, so let's get started. Visit the description section of this video and you'll get a link that takes you to this page, a page that looks like this. Once you get to this page, you can click on the sample practice resource. That's the one that you're going to be using for this particular session. It's the one that you're seeing on the screen. But again, if you're an Afterwork member, if you would want to learn a bit more, be sure to consider becoming an Afterwork member, and you get access to the practice resource, or the practice sample, the practice notebook that contains all the challenges. The sample challenge, the sample notebook only contains just a few challenges to just get you started. Right, so let's get started. The first thing that you need to do is to go to File, then Save a Copy in Drive. Click on that, and it should open a new copy in a new tab, and you can close the original copy and then we can use that one. I won't be making any changes to I won't be making any changes to this notebook, so I won't go through that step. I'll just open mine in playground mode. But having your own copy just allows you to save that notebook somewhere, and you can always refer to that notebook in the future. Right, so here we go. Let's connect our notebook to Google Drive, to Google servers. So by clicking on connect, it should take a few seconds. And then once connected, then we can get started. So first of all, under prerequisites, we're going to import the Pandas library, which we are learning how to work with. And then we're going to go through now the first concept. So the first concept entails specifying column names in order to focus on the data that we want for analysis. So sometimes you might have a data set that has 100 records. We might want to just work with just a few records. So this is how we are able to, this concept will allow us to be able to just focus our analysis on those columns that we want. So let's first of all load this data set, the healthcare data set. It contains the following information, assuming we wanted to focus on patient name, age, diagnosis, treatment, medication, and doctor. Then we can specify the data, those data columns, by specifying the data frame, that's df, then square brackets, then we pass a list of the column names that we want to that. So we have patient name, that list will contain the columns that we want. So patient name, age, diagnosis, treatment, medication, doctor. And yeah, so once we do that, we'll have selected the data and we store it in selected data variable, and we can display the selected data as shown. So this is the data that we can work with. It just helps with also ensuring that you do not have irrelevant information in your analysis. If maybe you wanted to perform some specific type of technique on the data, and this is our data of interest, then it helps with regards to that. So pause the video and then work on this challenge that we've shared here. All right, moving on, data cleaning and pre-processing. When it comes to working with data, we would need to perform data cleaning techniques or data pre-processing techniques for various reasons. One of them being that, the quality of our analysis would be dependent on how clean the data we have is. So so let's learn how to perform a few data cleaning techniques. You'll actually get to learn how to perform 3 techniques: how to handle missing values, like drop those missing values that we do not want in our data set. By missing values, I mean drop those records that have missing values that we do not want. We are also going to learn how to remove duplicates from our data set, and also how to convert a particular column to have a specific data type, which a data type is just a classification. So let's load this data set that we get. It's different from the previous one. So this is how this data set looks like. It just contains information about patients. Then we can handle missing values. So assuming that we wanted to drop any record that has missing values, we can use the drop NA function. We apply it to the DF data frame. So this data frame, and we set the value of the in-place parameter to true, so that we're able to apply this change by this function to the original data frame. So this will just apply the change to the original data frame. Then once we do that, we apply the drop duplicates function to drop any duplicates. So if a record is similar to another record, if it contains values similar to other records, then we are going to remove those duplicates. And then we convert the admission date column. So admission date column, which is here, we convert it so that it has a date time format, or a data type. It's a data type. So data types are classifications that we give to column names, or columns, not column names, but just columns that allow us to perform just specific types of operations after. So if we wanted to maybe assign, we could assign integer data type to age column, which would mean that we can perform mathematical operations. We could also apply a string data type to this column, gender, which allows us to perform concatenation, like combining textual data. So just a lot of text operations. But now for admission date, because it's of a date data type, it's data, it's date. The nature of this type of data is date data. So we assign it a date time format that allows us to apply date functions, which give us just the ability to just do a whole lot of operations and answer research questions in relation to dates. Like if we wanted to get records in between a certain range of dates, then we can do that. So we apply now the date time format using toDate time function, and we specify the column that we want. So df admission date, and then we replace the original column name with that, and then we with the results of this. And then after that, we now check for missing values to just confirm this operation, whether we have any records with missing values. Also, we check for duplicate records. We could also check for the data type. So I can even just write over here the data types for the DF data frame by just simply writing this. I'll just add a print function so that I can also display that. And we want also to confirm this last operation. So let's run this. So here we have no missing values across all columns. Here we have admission date with data time, and then duplicate rows. It's actually the 0 that we see here. All right, pause the video and then work on the challenge. Data aggregation and grouping. Sometimes you might want to create summary tables out of bigger tables. So if you have a larger data set, like the one that we are going to load right now, we might want to create a smaller table, which is usually called a pivot table, out of this column. And that table would need to be derived from one particular variable. So actually can be 2 or 3 or more, but in our case, we just want to derive it actually from 2. Diagnosis, we want to get diagnosis to be one column in that smaller table, and the other column in that smaller table will be age. So we want diagnosis and the age, but now we want the mean of that age. So we'll have 2 columns in that pivot table or summary table. Well, on the left-hand side, we'll have diagnosis, and the right-hand side, we'll have the average of age. So how do we do that? We use the group by function. So first of all, we reference the DF data frame. Then we use the group by function, which takes in what you see here, which is the column on the left-hand side. That's diagnosis. And specify on the right-hand side, we want to take age, but the mean value of that. And we also apply a reset index function so that we have a a data frame that we can still continue working with when it comes to analysis. So we store the result of this inside the diagnosis average age, and then we display the results of the pivot table, which you can see here. Diagnosis and age, allergy, the average age for patients was 35, etc. Right, this is one table. Sometimes you might want to just create a summary table out of just one variable. Here we had two variables or two columns. So assuming we wanted to create a summary table that has gender and then the number of patients for each, how many number of patients were there for each, let's say male and female. That's the table that we want to have, gender as well as the count of male and count of female. So how do we do that? We use the group by function. We specify the column and then apply the size function to be able to do that aggregation to count the number of patients. So we have gender, then female, then we have 30, male 30, which means that it's a balanced data set. So if you're an Afterwork member, you'll note that you have a challenge in this third section. So if this is the practice notebook, there's a challenge over here. Pause the video and then work on that. All right, moving on, Boolean indexing filtering. So sometimes you might want to filter for data. So initially, we got to learn how to filter for columns, the columns that we want to work with. But what if we wanted to filter for the records that we want? So assuming that we have this data set, and this is the data set, and we wanted to filter for records where maybe job title is equals to software developer, or location is equals to New York, then work with only those New York, let's say, records. How do we do that? We use what is called, there are many techniques, but one of the common or the basic techniques in Pandas is usually through the use, it's called Boolean indexing filtering or Boolean filtering. So what happens is that with this technique, we usually specify what is called a Boolean mask, which is just a condition. Data, we define the column that we want to filter by. So data salary, our data frame is called data, by the way. So data, that's a salary column. And because it's a condition, we would need to have an operator, logical, not, is it, no, it's just an operator. And less than operator, which is here. So we want data salary less than 75,000. So generally, this is our condition. We want records for records that have salary less than 75,000, and we save that in mask, that the mask variable, and then we apply this mask, which technically, when it comes to Pandas, we call it a Boolean mask. It contains our condition. We apply it to the data frame, the original data frame, to be able to filter the data set and get the records that we want. Awesome. Pause the video and then work on the challenge. We can combine multiple filters. So here we have just one particular Boolean mask. We can have multiple of them. And how do we do that? We usually use a logical operator. So we use what is called the AND logical operator. So let's load this data set here. This is our data set. It's another data set. We have a variety of data sets that allow us to just work on different types of problems. So assuming that we wanted to filter the data set based on multiple conditions. So based on this condition, this is the first one. And when you look at this closely, this is actually a mask, but it's actually two of them, two Boolean masks. So here we have one mask, but we could also have another mask that has maybe the data salary greater than 60,000. Then we can pass them to the mask itself, to the original data frame. So it's almost the same, but now each and every Boolean mask, we enclose it in parentheses. So here, this is the first one. And here we're saying equal to. When it comes to checking for whether column has a values equal to a certain value, then we usually use a double equal sign. For less than, it's less than operator, or greater than operator, or even if we wanted to say less than or equal to, we usually use this operator, less than or equal to, or we can do greater than or equal to. So we filter this data set based on these two conditions. So the first condition, we enclose it in square bracket and then use an AND operator, which is just an ampersand. On the keyboard, it's usually Shift, then 7. then we define the second one. And you can have different conditions for each and every Boolean mask that you have. Then we store the result in filter data and then display that. And you can see the records here: diagnosis, arthritis, which is here, then treatment, physical therapy, which is here. Pause the video. If you're an Afterwork member, you'll note that we also have a challenge. So yeah, there's a challenge here. So pause the video and then work on that challenge. Negating filters with not. So sometimes you might want to negate. So if you don't want to get these records that we see here, assuming that we don't want to get these records, we want to get the opposite of them, like, the ones that are excluded, the ones that we've left, we can use what is called the not operator. It just allows us to select all records where a column value is not equal to a specific value. So let's load this data set. So here we initially wanted to specify that we wanted to select records with diagnosis equal to GARD or GARD. But again, we want to select the records that are not equal to that condition. So we would enclose that Boolean mask with parentheses. Those are the brackets that you see here. And then we would apply in front with a tiled. A tiled operator is the one that when you press shift, then the button that's on the left of your keyboard of 1. So on your keyboard, there's the numbers 1, 2, 3, but there's a button that's just on the left of 1. The tiled, it's called a tiled operator, or not operator, symbol. So we apply it there. So it will get the records that do not have this particular value in the diagnosis column. So for diagnosis, you can see these are the records. All right, pause the video and then work on the challenge. Combining filters. So sometimes you might want to, so here, let me show you. Here we had and operators. Sometimes you might want to, so for this particular case, we wanted records which have both of these conditions true. So the records, if a record had only just one of these conditions true, we wouldn't get it, but because we wanted to have both conditions true. But if we wanted to get now either of the records, either of the conditions to be true, we usually use this operator. I'm getting the name. It's called a pipe operator. Yes, a pipe operator. It's just on top of where is it? Where did I specify? Actually, where is it? I actually did. I have used it. It's actually the key on top of enter. My keyboard is a bit confusing, so it doesn't show the actual character, but there's below the backspace keyboard on your keyboard, there's a backspace key. The one that you usually delete characters with. So below it, there's a button, then the enter key. So below that, you'll find there. But it depends with just the different keyboards. Sometimes you might find it in a different location. So that's what we're learning in the in section 7. So we're using the this operator, it's usually a pipe operator, or the OR operator. In some cases you call it pipe, but I think in Python they've called it, okay, this is one of those names, but an OR operator. So to specify that we want either of these conditions turning out to be true, then we'll get now the records. So yeah, so let's run this and get those records. Yeah, so you'll see that age is greater than 50, either that or diagnosis is cancer. Like diagnosis for this is osteoporosis, porosis, and in this case it's not cancer, but it's the record is greater than 55. All right, moving on. By the way, if you're an Afterwork member, we have a challenge for section 8. All right, and section 9, sorry, no, section 7, sorry. Section 7, you find a challenge as well. Moving on to string extraction, sometime we might want to filter for records that contains some text, not just exact as we have seen here, but some text. Maybe you have anxiety disorder as a text, but again, if you want to just get filter for records with just any of this text, then we use a string function. So it's a str.contains, which just specifies that we want to get the records that contain this particular piece of text inside the diagnosis column. So here we are specifying inside the diagnosis column, want to select records that contain anxiety, and we will display that. Let's load this first, our data set, and then we filter for those records. So you can see we have that, but what if I do, okay, let me not do that. I can still, because we have all the data that we have here. All right, pause the video and then work on the challenge. Date range filtering. So sometimes you might want to filter for records based on maybe specific dates, maybe maybe dates that records that have dates that fall within a specified range of dates. So let's load this data set, and then we are going to perform that. And remember, earlier I had mentioned to you that in order to perform date operations or data techniques or date techniques, we would need to convert the we need to assign the date time data type to the respective columns, date columns. So here we have two date columns. We have admission date and we have discharge date, and this is how we are assigning the two date functions. So we are assigning we're assigning those two columns, the date time format or date time data type. And then we define our range for starting. So we want our start date to be this particular date. And we would need to ensure that it's in this format. Like we have year dash month dash now the date, then end date as well. And then we apply some date range filtering. So here we can specify df, then we use a query function, which we can actually, by the way, use also for filtering of just normal data. But for now, we're just going to learn how to just work with this function for date cases. So we specify, we put quotes, just one single quote from the beginning and the end. It's a string technically. Then here we specify the date that we want to use using delimiter characters. So this is just usually it's actually the same key on the left of one where you had gotten the tiled. When you press shift, gotten a tiled, it's the same key. So to get this particular character, that's a delimiter character, then we specify, we can close our column, the first one that we want to check for the condition with this, because this is multiple words. If we had just one word, we could, for this column name, we would have just used without these delimiter characters. Then we want to check for admission date greater than or equal to at start date. So we use an expression here at start date and discharge date at end date. This just allows us to be able to access now this particular variable that we had earlier on set. So, and over here, we could also use or, but for now, we just want to ensure that, we could have actually used or and gotten a different kind of a result, but that's not what we want. Once dates the time between those two particular cases. And then we specify now our other discharge dates condition, which is at end date, and we get the records themselves. So we'll get records for patients who are discharged, were admitted between those two particular dates and discharged between those two particular dates. Right? If you're an After Work member for this challenge, challenge 9, we also have a challenge for you. And 10, moving on to the last concept, we can customize, we can perform just custom function filtering. So sometimes you might have some filter. Maybe you might want to perform some filtering technique that may be a bit complex. Instead, what we can do, because you might realize it's not supported by just the standard filtering functions or methods. So what we can do is to define a custom function so that performs some custom filter. And then what it would do is it would take in the row or the row that we give it. Then it checks for the column, that for that row, each column, is it greater than 50? And also, is it maybe equal to diabetes? We can also have some other conditions. Then once that is done, we can use, so this is now what is returned by the function. So we get the records, which it actually returns whether that particular record is satisfy this particular condition. If it does, we use then, by the way, to apply this function, we use an apply function that we apply to the df data frame. So df.apply, then we specify the column or the function that we want, custom filter, not the column. And we specify that we want to apply this across the records. Access is equals to 1 is usually across the records. And yeah, we store that in filter data and display the outcome of that. So this is just an easier way of being able to apply your own custom function that you've defined in order to filter for records based on certain column values. And that's it. Right, so that's it in terms of that particular case. You can have a look at the challenge for challenge 10 if you're an Afterwork member, and you can work on that. All right, so what's the next step? We'll be moving on to day 3. The idea is that by the end of it all, you have gone through some of these concepts, and they'll be repetitive. In some cases, you might even have noticed there are a few repetitive concepts in this challenge, Pandas challenge. And the idea is that over time, by the time we get to later challenges, you are able to just with confidence apply the concepts and feel as if, Pandas just feels second nature. So yeah, so that's it with regards to the session. If you found this session helpful, be sure to give this video a thumbs up. It tells us that we're doing something good. If you'd want to be informed when we post the next session, feel free to subscribe, and also have a look at the email newsletter link that we've also shared that is only for just this challenge itself. All right, all the best in your learning journey, and bye-bye.